Hi ho, in this video we're going to have a look at the discriminant, and it's going to be the first of a series of videos. This one will just introduce the discriminant, what it means and what its impact is, and then in subsequent videos I'll go through one example at a time over the more common sorts of problems. So the discriminant is formed from looking at the general form of a quadratic, which is y equals ax squared plus bx plus c. A is the coefficient of the x squared, b is the coefficient of x, and c is the constant term. And only a cannot be equal to 0. Everything else is up for grabs. So b could be 0, c could be 0. Okay, so the discriminant is defined as such. It's delta equals b squared minus 4ac. So that triangle there is called delta, Greek capital letter of the Greek alphabet, and b squared minus 4ac. Now, the b squared minus 4ac comes from the quadratic formula. So just to remind you, the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac. Hello, all over 2a. I could write it if I was being, I don't know, dramatic, I suppose, that negative b plus or minus the square root of delta over 2a, where delta equals b squared minus 4ac. Okay, now the reason why it's important to point that out, that's where it comes from, is because in the grand scheme of things, if this is how we can solve for x, remember, this is the two x-intercepts, or if I set the equation equal to 0, it's the two solutions for x. Then what's happening underneath the square root sign will tell you a lot about what's happening with the x-intercepts, or the solutions to the equation when it's equal to 0. So what do I mean by that? You can see in slide 3 there, I haven't got it quite zoomed out properly. Let me go in a little bit. There we go. You can see in slide 3, I've got the phrase nature and number. Instead of nature, sometimes it's type. The discriminant tells us something about the nature or the type of solution, and it also tells us something about how many solutions, or it might be the roots of the equation, or it might be the x-intercepts. They all mean the same thing. Okay, so number of roots, or number of solutions, or number of x-intercepts. Let's just have a look at this in tandem. We've got delta less than 0 here, i.e. delta is negative, i.e. the discriminant is negative, i.e. this bit is negative. What happens when you try to take the square root of a negative number? Well, if you do it on your calculator, you get error. In real life, you say D and E does not exist. And to be more precise, it does not exist as a real number. It does exist in a more complex kind of situation, as an imaginary number. And the set of numbers is called the complex set of numbers, as opposed to the real set of numbers. So when the square root, when b squared minus 4ac is negative, this will be the square root of a negative number, and therefore this whole thing will not be able to be evaluated. And therefore, if the discriminant is less than 0, there are no real roots. Graphically, it kind of would look like this, right? Left or right, you'll have your parabola being all the way above the x-axis, or maybe all the way below the x-axis. Could be to the left or the right of the y-axis, but nevertheless, it'll be up or above or below, i.e. it will not actually go through the x-axis. So there are no real roots, no real solutions, no real x-intercepts. What about delta equal to 0? When delta is equal to 0, this means that the discriminant is equal to 0. This means that underneath the square root sign, we have the square root of 0. And the square root of 0 is 0. Now, whether you add 0 or subtract 0, you're going to get the same value, and that's negative b on 2a, which you might remember is also the x-coordinate of the turning point. So you've got negative b on 2a with nothing else. And so how many solutions have you got? How many roots have you got? Got one, haven't you? So when delta is equal to 0, you've got one real root. And remember, root, solution, x-intercept if we're graphing. Don't forget you can have a quadratic equation, which isn't a function. So same sort of language there. Well, what happens if delta is greater than 0? Then that's okay. The discriminant is just a positive number, which means the square root of it will resolve into two possibilities, plus whatever the square root is, or minus whatever the square root is. Let me just pretend that b squared minus 4ac somehow turns into the value 9. Then if I go the square root of 9, I get 3, and so you'll have negative b plus 3 over 2a and negative b minus 3 over 2a. So you'll have two real roots. So I'll put that down, 2 real roots. You'll sometimes see the word distinct as well. Sometimes you'll say if the discriminant is equal to 0, there is one distinct root and two distinct roots. Distinct means separate from each other, because sometimes you can say that this is actually what we call a double root or a double intercept. I haven't drawn the graphs off to the side for the main reason that I forgot. So when it's got one real root, what must that look like for a quadratic function? Well, it means that the graph is going down to the x-intercept, hits it, and bounces off. So it's got a single distinct root. Or, if you like, if it's a frowny graph, concave down, hits it, and then bounces off. So when the discriminant is equal to 0, you would expect to see a bounce on the graph. Okay, misses the x-axis, bounces on the x-axis, and for two real roots, you can probably figure that out. It's going to be, oh, that's pretty dodgy. Try that again. Like that, or like that. But you've got distinctly two places where it cuts through the x-axis. And that's basically it. In the next series of videos, we'll have a look at a few examples so that you can see how you can take that knowledge to answer some questions.